I would be looking to nominate probably a CMMS champion in the organisation, and that CMMS champion is actually going to look after the master data, police the updates if you like, checking for the 3 C's to make sure that it's complete, it's correct and consistent, and actually, looking after that data as their main job function, particularly if you're looking at a fairly large manufacturing plant.
Hi everyone, I'm glad you're here. This podcast is all about modern day engineering and maintenance challenges, and most importantly, the role of IT to make the workplace easier, safer, and better. It's a space to share insights, have meaningful conversations, and find practical solutions together. Thanks for tuning in. Hope you find value in our discussions and enjoy our content. Hi, Gordon. Welcome to SHIFTLog, the Enterprise Asset Management podcast. Thank you for joining in. Hope you're well today.
I'm very well. Yourself?
I'm very good. Thank you. Before we get into the topic for today, Gordon, let's start things in style. Why don't you give an introduction about who you are, what your background is?
Certainly. My name's Gordon Ellis. I'm the Principal Maintenance and Reliability Engineer with Oil Plus, based here in our Aberdeen office. Started off my life many years ago studying engineering at the University of Aberdeen, and I had done that deliberately because I wasn't quite sure what kind of engineer I wanted to be. They did a sort of general engineering course, but as that course progressed, I had kind of focused more and more in electrical and electronic. And at one point, I was the treasurer of the younger member section of the IEE, now the IET. When I joined industry, I started off my career actually writing software. I developed a software package called Polymanager, which was used for doing vibration monitoring of rotating equipment. And I started training people in how to work the software, and that kind of naturally led to me then training people on how to actually interpret the results of the vibration monitoring. And that kind of set me down a path of getting very involved in rotating equipment and condition-based maintenance. Did that for a number of years and then had a brief outbreak working for another company, an e-learning company, doing something completely different. And then in 2005, I came back into a sort of engineering background, but I was now, I joined a company called Expediate at the time, who were basically doing maintenance data builds, but had picked up a contract for condition monitoring. So I came in initially just to set that contract up and then leave, but they didn't tell me not to come back. So I just stayed, and they kept paying the bills, which was more important. I kept paying the wages. So I ended up sort of running their condition monitoring department, but I enjoyed doing training, and it kind of logically led to me helping to facilitate criticality workshops and failure modes affecting criticality analysis workshops. And that, I always say when I'm doing that, I'm not the expert in the room. My role is to bring the expertise out the guys from the company, but you need to know a bit about the background. So that led me into getting into maintenance data builds, and I went on to some quite big and some quite small projects and maintenance data builds. So that's kind of an abridged version of a 35-year career.
That's a good amount of engineering experience at the same time. I didn't realize that you were involved in software builds and have that knowledge. That clearly adds to the role that you're playing right now, I believe.
Yeah, I mean, I think you find nowadays that you're always involved with IT to some extent. So having a good IT grounding and the sort of logic of the software programming. Now, to be fair, when I was doing software programming, it was in DOS. Yeah, when Windows came in, I had a team to do that. So yeah, it was quite a few years ago, but yeah, it's a very useful background, I think.
Yeah, time goes by, isn't it? Technology catches up. You talked about engineering data builds. In your current role, Gordon, is that solely what you're performing, engineering data builds and supporting those projects, and then playing a role in those projects?
So the main focus of Oil Plus is in maintenance data, supporting maintenance data for CMMS. I also get involved in some other things. I'm doing a performance standard review for one client just now, and I'm also helping some clients with sort of defining their criticality standard for use internally. So it's quite varied, but the maintenance data is a big chunk of what we do.
Awesome. Thanks, Gordon. For those of you are listening to this podcast, let's first start explaining what an engineering data build is.
Basically, what you're doing in your engineering data build is you're actually populating the master data within the CMMS. It's really important that you do that properly because we all know the statement garbage in, garbage out. And that master data actually encompasses the essential data about your assets, your maintenance procedures, your maintenance spares, and any gaps in it can lead to emissions, wrong activities, all sorts of stuff. We always say that the fundamental QA really is the three C's: the completeness, correctness, and consistency. Making sure that you've got a complete list of what you're wanting to maintain within your asset register and making sure that it's correctly identified and you're consistently applying your maintenance. And if you do that, it helps you to support all sorts of things in the future, such as going for ISO 55001, the Asset Management Standard Accreditation, allows you to support your risk management and also your critical systems. Perhaps to go on and expand a little bit on what the individual elements of the sort of master data are, there's really a number of bits and pieces which constitute that in total.
Just to give a little bit of context around that, usually companies, I believe, reach out to you and then say that, look, the data is not in great shape. So is that how the exercise starts? And then you kind of engage and then make sure the data is cleansed and rebuilt so that the quality or the gap in the quality in the data is then fixed? Is that where it starts from usually?
It can actually start from a number of sources. Sometimes it will come about because the client's actually doing a complete new build. So it's a greenfield site and they're just starting with a fresh sheet of paper and they need to do a maintenance build from scratch. Quite often it will be because of project work, though, that they've actually got an existing facility, but they're wanting to add something to it. And again, you've got a clean sheet of paper on what you're actually adding. Quite a lot, increasingly, we do find, though, that I touched briefly on ISO 55001 earlier, the sort of standard for asset management. Companies like ourselves can go in and do an audit against that standard for a client, and that will actually help to identify any gaps and emissions in their maintenance systems and underlying maintenance data that supports that. And that is quite a common route for us just now to actually get a work scope defined. It's quite useful, actually. It's quite good for us because we come in on a consultancy basis to actually tell you where your gaps are, and surprise, surprise, we can help you fill those gaps and fix them. Worst case, of course, probably the worst place to find yourself in a maintenance build is if you've had a sort of improvement notice from the HSE as a result of your maintenance data not being very good. Perhaps your backlog's too bad, or one of the underlying principles of 55001 is maintaining a clear line of sight between your sort of maintenance objectives and how your maintenance is done. And if that gets muddied, then the HSE can get a little bit hot under the collar.
Yeah. Gordon, in your experience, is it very clear to establish, looking at the way a CMMS is functioning or the reports are functioning, is it easy to establish a line of sight between that and the poor quality of data?
Usually, yes. It's probably not completely apparent on scratching the surface. The audit process that we would go through would actually go and kind of delve into the sort of some interview scenarios and talking to people. And it's when you start to talk to people and you actually learn the problems that they are having. The maintenance management system should be there to support them. It should be making their life easier, not harder. And it's by kind of looking at the combination of what's in the data, how it's built, doing a sort of taking an extract of their asset register, for example, and actually looking to see how complete and correct that looks. Perhaps doing a sample against a couple of drawings actually will help you pick up these issues as well. So on the surface, it's usually looks better than it does when you start digging in.
Right. And I think you mentioned about ISO audit. Is that a type of audit that you perform when an organization reports there are, ongoing issues? And then is that one of the things that could point to issues in the data?
Well, yes, that audit process is, as I say, as part of that, we'll talk to the users, we'll have a look at the data structure within the CMMS, and they may have done that either because they feel that they have a problem, or maybe they just want to go for 55,001 accreditation, or just do things better. Quite often our clients think they're actually in a reasonably good place when they come for an audit, and then find, yeah, maybe the gaps are slightly bigger than they had envisaged.
Okay, so that serves as a prerequisite, what you say, unless you are absolutely sure as a company that the problem is with data.
Yes.
Okay, right. So going in a little bit more into this exercise of engineering data builds, and is that right, saying that what you perform is ultimately building and supplying a data set that goes into CMMS? Do you also usually get involved in porting this information into the CMMS, or usually is that carried out by their IT partners, IT part of the organization of the client?
Yeah, usually the client will either handle that internally or have a specialist vendor for actually maintaining the CMS. What we will do is we will agree an upload standard with the person that's going to actually be loading it, and we will
Right.
populate an upload file which will actually be used to do the configuration of the system at the end of the day. We've always tended to test that very early on in the process, because the last thing you want to do is get to day 31 of the month, the last month that you're delivering, and then find that your upload file doesn't work. So we always document it well, test it well, and yeah, it goes very smoothly if you take those steps along the way.
Fantastic. On to engineering data build then. So we established the output of the engineering data build goes into CMMS, done by mostly the partners the client usually engage with, right? So what sort of activities are involved in an engineering data build? Just walk us through in high level, step by step, as to where do you start and what type of work that you do, and then how do you come up with the final upload files?
Yeah, so the starting point will always, of course, be a kick-off meeting. And at that kick-off meeting, we want to agree responsibilities, lines of communication, and also what standards the company is actually working to. So do they have a particular specification for their functional locations, for their equipment standards, and along with those equipment standards, what technical attributes they actually need to collect and actually populate into the CMS at the end of the day. We also look for standards in things like, for example, defining the bill of materials to actually load their spare parts into their software. Next stage is kind of the roll your sleeves up and get on with it, is data and documentation gathering. So actually, what are the sources of the data that's going to go into the CMMS? Is it a brownfield site, in which case there is already legacy data, and we probably will need to look at how we're going to cleanse that and load it. And if not, if it's a project or a greenfield site, where is the documentation? Where's the asset register? Is it held centrally? You'll probably find that if it's a greenfield site, there'll be a number of OEMs involved along the way, and they're probably all got their own little data set. So you need to look at how you're going to pull all those together, along with the document gathering. Then start working on the sort of asset register development and your actual hierarchy build within that asset register. So defining the functional locations and defining the parent and child relationships, usually by function. So if we've got a pump, the motor will be a child of the pump. The thermocouple and the motor windings will then be a child of the motor. We start building that asset register, and it can be a reasonably detailed job, going down to actually scraping data off of P&IDs and process flow diagrams. Or it may be that we have more or less the database there if it's an improvement project. But we also, coming back to the three C's of completeness, consistency, and correctness, we want to make sure if it's a brownfield site that we have consistent data there. This is actually complete. So we'll probably do a check against some P&IDs, even if the client thinks that everything is actually complete in their database. just to make sure. We'll then go into a sort of criticality assessment process. Our maintenance bills are always risk-based. So what's the risk that you've actually got with a piece of equipment failing, and what appropriate maintenance are you going to put in place? And as we go on to develop the maintenance strategies, we'll maybe do the more critical stuff at a more detailed or a shorter interval than the less critical stuff, longer intervals, and non-critical stuff, well, perhaps run to failure is actually the correct thing for that. We do it by doing a fairly high-level criticality assessment first at the main package level or equipment level. So how important is the pump? How important is the compressor? And we will usually take a kind of rule of thumb around 20% of the plant into a more detailed criticality review and a failure modes effect and criticality analysis. And the remainder we'll actually do generic strategies on. We'll actually look at how we maintain a motor. Doesn't really differ that much across the vast majority of motors, so we'll apply the same maintenance across them. We'll also at that time begin the work of actually identifying any safety or equipment critical elements, and also any SIL and SIF instrumentation that needs to be maintained. In parallel, so we've got the asset register going, we've got the criticality process going on. We'll probably then actually start identifying the spare parts and the bill of materials that are required. And we'll look to build BOMs from two perspectives. One is a task BOM. So if you're going out to maintain a pump and you're changing the seal, what do you actually need to do that? What spare parts are you going to need? And then we'll also do an equipment bill of material, which is actually looking at everything you might need on the pump and the motor set, potentially even down to things like a new lid for the control panel. Yeah, this stuff can be very detailed. So we'll actually kind of compile that stuff at the same time as we're then going on to do the actual maintenance strategies and the task list development. So how are we going to maintain the pump? What work instructions are needed for doing your vibration monitoring, lube oil analysis if appropriate, seal change out and things like that. Then we'll go, once we've got both of those sort of elements defined, we'll go into actually doing the sort of maintenance workload smoothing and optimization. And then once you've got all that together, that's when you can then actually look to actually upload it into the CMMS and provide the final solution, if you like.
Yeah, quite a detailed, structured process, isn't it? You have to, one leads to the other nicely. So you have to manage it well.
Yes, these projects. I've been involved in some projects which are like, for example, adding some gas compression packages to a facility in the Middle East for distributing gas, and that was actually a 4-month project from start to finish. I've also been involved in a maintenance build for an offshore asset which had 3 fixed structures and a floating offloading, storage and offloading vessel. And that was like 2 years and had a team of up to about 14 people working on it at one point. Team size grew and shrank throughout the project. So yes, they can be very varied and fairly small to rather big. Where it's a maintenance improvement, of course, project, a maintenance enhancement, so it's a result of we've come in and done an audit, we will quite often break it down into bite-sized chunks. So maybe the first thing we'll do is we'll get the asset register fixed, get that asset register on the hierarchy correct, and then we'll go back, once we've done that, and they're beginning to see some benefits of that, we can then go back and actually say, well, what's the BOMs? What bill of materials do you need to support this? And what strategies do you need? So yeah, we'll tend to, particularly in a maintenance improvement process, maintenance enhancement, try and break it down into bite-sized chunks so that the client can see the benefit of the improvements as they come along and not wait 2 years at the end waiting for the final outcome. And B, they can be quite intensive, these, for the client as well. So it's making sure that we're breaking it down into chunks that they can support and they can make the engineers available to answer our questions.
Okay, great. And thanks, Gordon. I think, in fact, you answered one of the questions I was actually after, which was the duration of the project. But what you said was that it could vary based on the ask, right?
It varies depending on the size of the asset and also, what information they've got available to an extent. But yeah, primarily it's driven by the size of the asset. Greenfield projects tend to be bigger, typically a year upwards. Brownfield sites can be as big. Yeah, the project work in particular tends to be quite a bit smaller, 4 to 6 months.
When you refer to greenfield and brownfield, are you referring to the fact that it's a newly established platform or a site with all the documents available, or are you referring to the fact that it's a greenfield CMMS implementation? So right from the beginning, you have to collect the data.
Yeah, so when I'm using greenfield, I'm really thinking of the asset itself. So a greenfield site is one that's not yet operated. It's still in the feed stage and it's still being developed, whereas a brownfield site is one that's been operating for some while.
Right. Yeah. So that's why brownfield could be done quickly because it's an operating site.
Correct.
So if you take just to get some context in terms of timing, right? So if you take a usual CMMS implementation, suppose a organization comes to you, well, we want to implement a CMMS or upgrade the CMMS to a different version. In SAP, a lot of the clients goes to S4 now from ECC. And then what quite a lot of clients do is treat this as a transformation. As part of the transformation, they address data quality as well. As far as the organization is concerned, it's a brownfield operating site. But as far as the CMMS is concerned, it could be a greenfield. That is, you're rebuilding the entire data set within the CMMS. In such cases, if you think of a company with 6 to 10 sites, what is a typical duration that you take, provided the fact that you have all the documentation available from OEMs?
Again, it will depend how complex their sites are, but I would certainly, if it was 6 or 7 sites, I would certainly hope to complete that transformation within probably a year at the most. Our approach would normally be in a situation like that is let's take one site as a pilot site. Not the smallest, because that's going to be too easy, but not the biggest. So go for one site and actually look at the process that we're going to go through and lifting that data out of the old system and putting it into the new system. You can, of course, do it electronically very quickly, but as you say, it's an opportunity to actually improve things. And again, we'll go in and we'll look from a sort of, consistency for a start. Is the naming convention for the functional locations consistently followed? Are they using different abbreviation, underscores, hyphens, forward slash backslashes, and also, is the functional location structurally right for supporting the work that they're trying to do? So yeah, typically we'd probably aim to do the pilot within 3 to 6 months and then go on to roll out to the other sites after that.
I believe that the typical objects that you would compile in the data build would be asset register, asset hierarchy, strategies, bill of material, and then maybe detailed work instructions as part of the strategies. Are those the most common ones that you would undertake?
Yeah, those are the most common. Yes.
Okay.
Absolutely.
And part of that.
Quite often, particularly if we were looking at the scenario of 6 or 7 sites, if the client has grown by acquisition, there's a reasonable chance that the 6 or 7 sites might be doing similar things, but not in exactly the same way. And it's those maintenance strategies and the work instructions that we would look to bring some consistency across all 6 and 7 sites, all the sites, so that you've actually got a better basis for building going forward. And actually, the sites can compare themselves and benchmark against each other then, because they're all doing the same sort of activities.
Okay. Do the data build exercise, Gordon, is it system agnostic?
Yeah, absolutely. The end of the day, the maintenance management systems all do very similar things. You need to obviously tailor the upload file, as we talked about earlier, to make sure that you're fully supporting all the features of the actual process. What we normally do is we'll take an extract, particularly if it's a transition project, we take an extract of what's in we'll load it into our own in-house developed tools, which we have kind of developed based around the process with built-in QA. and we'll actually manipulate the data within that. We will do the restructuring if we need to rebuild the hierarchy. We'll fix any tag issues. We will add any missing tags by referring back to P and IDs, etc. if required. And then once we've kind of got the build within our system, that's when we do the upload file to actually do it. So yeah, we can support SAP, we can support Maximo, Maze, Star, all the sort of standard packages, and the process that we follow doesn't actually change much at all, and that's embedded within our software.
Okay, great. And I believe the approach that you follow is industry agnostic as well.
We would apply the same processes, whether it was oil and gas or whether it was a water treatment plant or even a freshwater plant. There is, of course, quite a lot of what we do is tied to ISO 14224 standard, which is actually the standard for petrochemical and oil and gas and natural gas. And we will, quite often use those things in ISO 14224 to apply to other industries. But, at the end of the day, a pump's a pump, whether it's been used in oil and gas or water distribution.
It's a very good point that you mentioned there, ISO 14224. Or in the last 2-3 years, there's this trend being built that there are a lot of things in that standard which is transferable to other industries, isn't it? Because of the level of detail it goes.
I mean, in essence, 14224 really does three main elements. It's got an equipment boundary which defines what you're actually looking at. It's the pump. Is the motor included in that boundary? Probably not. You look at the motor separately, and that's common across industries. It's then kind of looking for an equipment taxonomy. So if it's a pump, what type of pump is it? And then it's looking at how you actually build the hierarchy, and that's totally transferable across certainly every industry that I've come across. One or two will use their own particular standards. Shipping, for example, tends not to use 14224 because they're very focused on their SFI classifications. But even then, they'll probably use the equipment taxonomies, the pump definition from 14224.
Yeah, thank you for that. Engineering database requires a specialist set of skills and then a dedicated team working on that. Do you think that's the reason why data build activities are outsourced by the organizations rather than appointing an internal team to carry out this?
I think it is one of the fundamental things is there are some quite specialist skills which come easily to people that actually do it all the time. But there are many other factors as well, just the sheer time pressures. Everybody's got their day job to do as well. And these projects can be quite intensive, even if they are, if it's a brownfield site and we've got a 4-month improvement window, then, 4 months out of your day job, 100% of the time is actually quite a big ask. So, yeah, partly I think the specialist nature of the job and the skills, but also just availability and also the focus to actually get on with it for the key personnel, I think, is another fact.
Okay. Now, you talked about this at the beginning of this, briefly touched upon this. If, suppose, I am part of the maintenance crew in an organization, what are the symptoms that I could see in CMMS or otherwise which point me towards a engineering data build as a person who is doing my day-to-day job in a maintenance or engineering team?
I think the most obvious sign is if when you go to execute the job, you find you cannot for various reasons. It may be that you go to execute the job and you don't actually have the spares to hand because there hasn't been a good link between your equipment data and your spares data, and they've not been able to. Worst case, they've not actually been able to find it in time. They do have it, they just don't know where it is, or actually they're not quite sure what they have. Or perhaps you go to execute the job and find that you've not actually got everything in place, such as scaffolding. These are all symptoms of not actually having very good underlying data. Delay in work is the most obvious one. If it's taking an awful lot of information, you're not actually getting your work delayed, you're getting it in time, but your planning team are working overtime to actually pull all this information together. And again, that's another symptom that there's probably underlying. Those are probably the most obvious ones. More subtly, I think if you're spending lots of time searching through the database for information in general, then your data's probably not very well structured.
I believe if you're struggling for data within the system, 9 out of 10 you're struggling to report as well, right?
Correct. Yes. Absolutely. Yes.
That goes without saying. We're getting towards the end of the session now. 2-3 questions more. If I picture myself being part of an organization, involve a data team to carry out an engineering data build and supply me files, I loaded that into my CMMS, all good from that point onwards. How do I make sure I sustain that quality within the CMMS so that I don't have to do a engineering data build again couple of years down the line? What are the tips?
I think the main theme is, who's actually going to look after that system for you. One of the mistakes that people can make is that they think, well, it's an IT system, so let's just leave it to the IT guys. That's not to criticize anybody in IT. I was there myself once, if you remember, as a software developer. But, they really need to make sure, yes, it can be somebody from IT, but they really need to understand the importance of what they're doing. I would be looking to nominate probably a CMMS champion in the organization. And that CMMS champion is actually going to look after the master data, police the updates, if you like, checking for the 3 C's to make sure that it's complete, it's correct and consistent, and actually, looking after that data as their main job function, particularly if you're looking at a fairly large manufacturing plant. Everybody, of course, has an input to the process, though. You cannot rely on the champion alone. You need to make sure that you have a very robust management of change process to ensure that any changes that come along are built to the CMMS data is updated to the same standards as you did in the first place. And the users, your maintenance, reliability engineers, technicians, they have a role to play as well in ensuring that any issues are highlighted for follow-up action, and also to ensure that you get a cycle of continuous improvement. And then it is a bit of work, but if you do that, you will get the benefits and being able to use your data meaningfully to support your reliability improvements. Feed in, of course, anything that goes along the way, any root cause analysis or any RCM workshops that you're doing as well.
Thanks, Gordon. We have seen a number of times that clients who wants to do an engineering data build struggles to get the business case right. Any tips that you can give in terms of how to quantify the poor data quality and justify an engineering data build project?
So actually justifying the benefits that you're going to get. The cost side, I think, is always very clear to see how much it's going to cost you to do this data. Quantifying how bad it is, I think it is. It's back to what problems it's causing you. Is it causing any delays in work? If you're not sure, then it probably is worth actually investing a little bit of time and effort in getting a maintenance audit done. It doesn't actually need to be a great in-depth process. You can actually do it internally. There are guidelines published by the likes of the Institute of Asset Management that actually, kind of give you a self-assessment questionnaire, if you like, almost, that you can go and fill that in, or you can have a company like us come in and do it for you. If a company comes in and to do it on your behalf, they're probably making it more evidence-based rather than just kind of gut feel. And I think that evidence probably helps to justify or quantify the problem and actually, make the case more sound. You're then, of course, balancing that up against your sort of benefits that you'd expect from having a good set of data, which will allow you to actually, having good master data will ensure that you can have good reporting and analytics with meaningful KPIs. Actually, obviously supports your accurate cost control and accounting. It helps you with your efficient maintenance execution, managing your spare parts inventories, and, potentially better identifying common spares and helping you to reduce your spare parts inventory. And it also helps you make sure you comply with regulatory compliance. And it helps even in things like, if you have new personnel coming on board, to actually, get them onboarded, get them up to speed with what you're actually doing, because you've got all that data to hand to actually present on.
Thanks, Gordon. That's the last question I had. I really enjoyed the session today, and then I'm sure everyone who listened must have found it very insightful, because this is a very contemporary topic, and the line of business, for example, we are in implementing SAP solutions. This particular topic comes over and over again. So I'm sure there'll be loads of questions which we will try to answer after the session. So thanks for your time. And hopefully we can do a session targeted towards some of the other specialisms that you offer as well further down the line.
Excellent. Thank you for the opportunity. And I enjoyed our chat. Thank you, Deepal.
Thanks, Gordon. Hope you enjoyed the conversation today. If you have any questions, thoughts, please drop in a comment. We'll pick them up. If you have any suggestions, topics that you want us to cover in future episodes, let us know that too. Thank you ever so much for tuning in. I'll see you next time.